Alright, this video is going to be a little bit different because I'm going to use the book. Since there's so many graphs, I thought it better just use the book graphs rather than my own awful graphs. So this is a really complicated lesson. I'm really surprised they put this in Algebra 1. I'm actually going to put this on the SAT website to show them how to do these graphs, because these things are on the SATs. We're going to do Lesson 110, vertical shifts, horizontal shifts, reflection about the x-axis, and combinations of shifts and reflections. This is even a lot for one lesson. So far we've learned about different types of graphs. Here we have, they call these the parent function when it starts at the point 0, 0. Here we have a parabola, and its function for parabola is f of x equals x squared, and it looks like that. Both arms go up. Over here we have a graph with the highest exponent of 3. It's an odd function, so one arm goes up and one arm goes down. The next one is the square root function, and we've done those before, and you should be able to recognize these. We've done these so that you could, before all you had to do was recognize these parent functions. And then finally we have what an absolute value function looks like. It's just like a V. These are the parent functions because they are just at the origin 0, 0. Now what we're going to do now is we're going to start modifying the function. So here's our new function. I'll show you the old one. This is the old one, f of x equals x squared. And the modified function is moved up 1. And you can see that the graph will move up 1 if you add a 1 on to the end. And of course if you subtracted a 1, it would have went from the 0, 0 down to negative 1, 0, negative 1. So if you add or subtract, the function moves up or down. Here is our g of x equals x cubed function. Here is the original function with the middle at 0, 0. Here is our modified function where we added a 1. Let's see if I can point to that at the same time. Okay, let's see. I'm not pointing. Here we go. Nope, I can't find my finger. Okay, this is pretty bad. So this function just moved up 1. Just moved, there we go. This was at 0, 0, and then it moved up 1. And that's because we're just adding a plus 1 to our function. Here we have the square root function. The original function was at 0, 0, and when we added a 1, it moved up 1 place. And finally our square root function, our absolute value function, it was a v at 0, 0, and when we added a 1, it moved up 1. And of course here we can do with the minus like I was telling you about. If you subtract 1, it moves down from 0, 0. Here's another one, the cubic function. When you subtract 1, it moves down. And the square root function, it moves down 1, and the absolute value, it just moved down 1. Here's the little rule for this. It says vertical shifts of graphs of a function. The graph of a function of f, where f of x equals f of x plus k, is the graph of f shifted vertically k units. So it's going to go up and down whatever k is. Okay, let's move. Here's our first example. It says sketch the graph of the absolute value of x plus 3. So they want just a general graph. So what we would do would we would do the absolute value graph, which is right here. You would just do the general. You see how they don't have any numbers on the graph? But they just want you to do the v at 0, 0. And this function over here is what happens when you add 3 to that. Well, all they did was they took the graph from 0, 0, and they moved it up 3, because that's our vertical shift. When you add it on or subtract it, it's your vertical shift. Okay, let's go on to horizontal shifts. This one's more complicated. So right now, if we start with our parabola, let me go back to our parent function. Here's our general parabola that starts at 0, 0. Now we're going to start moving our functions to the left and to the right. And how do you do that, you might ask? Well, let's look here. Here's our parabola. It has the function f of x, I wish I could get my finger in the right spot. Okay, f of x equals x minus 1 quantity squared. So instead of adding it on the end, you're adding it inside parentheses. And whenever you do something inside of the parentheses, it's going to move to the left or the right. Now you would think because it's a minus 1, it would move to the left one. But when it's a minus 1, you actually move to the right one. Because if we would put the 1 in there, we would get our 0. So it's the opposite of whatever's in there. Let's look at the next one. This is our cubic function, minus 1. The whole thing went from, it's in the parentheses. It's in the parentheses, the minus 1 is in the parentheses, so it's going to move to the right, not to the left, even though it's minus. It's going to move to the left one. The same here with our cubic, or our square root one. We're subtracting 1 and it's underneath the square root, so it's going to move to the right one. And here is our absolute value. We subtracted it inside the absolute value, so it moves to the right one. And they're just going to show us some examples of moving it to the left. If it's a plus 1, you would move it to the left one. Here's the next one, plus 1, we move it to the left one. Plus 1, we moved it to the left. And plus 1, we moved it to the left. So it's either in parentheses or it's in the absolute value or square roots. Let's look at the little rule that goes with horizontal shifts. It says horizontal shifts of graphs of a function. The graph of a function of f, where f of x equals f, in parentheses, x minus k, is the graph of f shifted horizontally k units. Don't let that confuse you. It's actually, they explain it a little bit, but we're not going to get into it completely. But you do it the opposite. If it's a negative k, you shift it positive k units. Okay, real quick, okay, here's an example. Sketch the graph of f of x equals the square root of x minus 3. So we take our square root function and we would move it to the right. Since it's negative 3, we move it to the right 3. And then it's still the same shape. You see there's no numbers here. They just want you to write the general shape. Okay, reflection about the x-axis. So this is our, if we go back to our parent function, here's our parent function. It's going up. We can reflect it around the x-axis by making the function negative. So if we put a negative in front of the x squared, the function flips. Let's do the next one. We put a negative instead of the x cubed, the function flips around the x-axis. This one, see how it flipped around the x-axis? It was on top. It was going this way, and now it's going underneath. And the absolute value just totally flipped. All we did here was put a negative in front of the absolute value, and it causes the whole thing to flip. Here's our little rule about this. It says the graph of a function f, where f of x equals negative f of x, is the graph of x reflected about the x-axis. So hopefully that isn't so hard for you. Now we're going to do combinations. Well, let's do the example first. Sketch the graph of f of negative x cubed. So typically this graph would have went like this, like that, but we flipped it around the x-axis, and so that's what it would look like. Now we're going to try some combinations. These are really tricky. It says sketch the graph of negative absolute value of x plus 3. So they're adding two things. They're going to flip it around the x-axis because we have that negative, and they're going to move it up 3. So what they suggest you do for these is you write the parent function. Here's our parent function. The next thing is we're going to flip it. We flipped it. And then the final thing is we're going to move it up 3. And that's how we do a combination. You start with the parent, then you do one of the other parts of the function, and then we do another part of the function. So let's just look at the examples that you're going to have for practice. This one is going to be a parabola, so it's going to start at 0, 0, and then you're going to move it up 3 units on the y-axis. This one, it's inside parentheses, so you're going to do a parabola, which is the U-shaped shape, and you're going to move it to the left 3 units. And over here we have a parabola, because it's x squared, and we're going to flip it because we've made it negative. So hopefully that all made sense. If not, we'll go over this in class. So do your best on these practice problems, and just remember you're doing complicated problems that we don't normally do till pre-calculus, but they put at the end of your Algebra 1 book just to get you familiar with it. So that's it for lesson 110.